All right, hi everyone. Welcome to Algebra 2 for this week. We are still finishing up Unit 1. You guys are scheduled for your test next Monday. So this is sort of like a Unit 1 test review today. If you are able to pre-print the notes that I gave you, that would be great. It's going to save you lots of time and effort with the writing down of questions. If you ever come in person, I hand you those notes. They're kind of lucky ducks this morning. And also, if you come in person, you automatically get full points for today's session, which is pretty fabulous. So today we're covering solving and graphing polynomials. So on our agenda, last week we did the first portions of Unit 1 where we talked about synthetic division, what happens when there's a remainder, and this week we're really going to focus on graphing and how to factor completely. So pause for just a minute, whether you're in person or at home, please write down my week 4 essential question because this is not part of the notes. I always take out this slide before I print them for you because I want to make sure you are paying attention. I'm kind of sneaky sometimes. So take a quick minute and copy down your week 4 essential question. Okay, great. So week 4 is going to be all about multiplicity and what it means and what it tells us about the graph. So we're going to jump right in. The test has a question that looks just like this, and it gives you a function and it asks you to evaluate that function for f of -3. So notice in place of the x, because we're used to seeing an x right there, they're putting in -3. So you have two ways that you can solve this problem. The first way is just to take the -3 and plug it in for every x. The other way that we've learned this unit is to use synthetic division. So let's take my -3 and put it out here in front. And then we're going to drop down my 3, my 2, and my 3. So take a quick moment and everybody please try synthetic division for this problem and see what you end up with. Okay, if you're at home, please type in your answer when you get it. So check your work. We know my first 3 drop straight down. -3 times 3 is -9. Add straight down. -3 times -7 is 21. Add straight down. So when you plug in -3, what answer do you get out of it? 24. So -3, 24 is going to be a point on my graph. Since this is not a 0, it's not a solution. Let's make sure we're clear about that. It's not a solution, but it is a point on the graph. So that goes back to our remainder theorem from last week. So if we ended with a 0 here, it was a solution. If there's no 0 there, then it's simply a point on my graph. So if I'm asking you to evaluate this function at -3, when you plug in -3, what was our remainder? 24. That's a test question. Let me pause for a minute. Any questions on this type of question? So if I put in f of 2, you do 2, you do synthetic division for 2, and see what your remainder was. If I said 0, plug in 0, try it, see what your remainder is. You are evaluating this graph at this point. You can also take the -3 and plug it in where you see the x to solve, but I think synthetic division is a lot less messy and there's less room for making mistakes when you use synthetic. Okay, now we're going to get into graphs, and you're actually going to like them more than maybe you think that you're going to like them. So let's talk about what information the graph shows us. The key pieces that we want to look at are the places where the graph is crossing your x-axis. So we're talking the -3. If you have your notes pre-printed, can you guys circle these for me? So circle the -3, circle the -1, circle the 2. So what information does the graph show us? The graph shows us our solution. So let's all write the word solutions. And let's write down my 3 solutions. So -3, -1, and 2. Those are my solutions. Okay, so once you have your solutions, you can take your solutions and write them as factors. So the -3 becomes my x plus 3. My -1 becomes my x plus 1. And the 2 becomes my x minus 2. So I just want to make sure that you guys are really comfortable going back and forth between solutions and factors. Any questions about that? So the graph shows us a lot, right? It didn't even have to tell me this blue equation. I could have found it myself. We're going to write out my solutions. Then we write them as the opposites inside the parentheses for the factors. So we can go one direction or the other direction depending on what it's asking us. Okay, let's try these two. So I'm going to pause for a minute and give you guys a second to try them. So for my graph on the left, what are the roots? And then what are the factors? My graph on the right, what are the roots? And then what are the factors? So try writing them on your paper. So let's talk about the graph on the left first. Everyone, let's identify my solutions. So I have one right here, one in the middle, and one right here. So my solutions, let's make sure we're labeling everything, would be -3. Where are my other two spots it crosses? Somebody in the room tell me? Where's this one in the middle? 0. And the one on the right? 3. Great job. So those are my solutions. So the graph tells us my solutions. Now how am I going to write my factors? Somebody? Okay, so Billy says x plus 3. Good job. How about, so that's for the -3, right? How about the +3? X minus 3. Good job. What do I do for the 0? Anybody know?
Just 0?
Not 0. So we can say x plus 0 or x minus 0. Because isn't that really what we did with my numbers, right? I put the -3 in as a +3. I'm going to put the 0 in as a, doesn't matter. And then I'm putting my 3 in as a -3. So this middle section technically can just be written as an x, if you want. So I have an x plus 3, an x, and an x minus 3. Look how many times my graph crosses the x-axis. 1, 2, 3. Guess what that means about the number of solutions I have? 3. Kind of interesting how everything's connected. Let's come over here. How many times does this parabola cross the x-axis? 2. So how many solutions is it going to have? 2. Good job. So let's write out the solutions for my red graph. My solutions will be -2 and +2. And please now write the factors. So I want you guys to be able to go both directions. So my -2 is going to become x plus 2, and my +2 will become an x minus 2. How are we feeling from graphs? Not bad? The graphs tell us a lot of information, right? Do you have a question?
For the second graph, the place that's on the y-axis, you just leave that alone?
Okay, great question. So the question is, what about the point that's on the y-axis? Do you leave that alone? And the answer is yes. Because if I'm looking for solutions, I'm only looking for the places where it crosses the x-axis. So even on this graph, technically, this is a high, that's a low, but I don't include them as solutions because they're not on my x-axis. Good question. This has a specific name, by the way. This would be your y-intercept, right, where it crosses your y-axis. So let's kind of go over my third question now. What are other vocabulary words used instead of root? So on a test, I could ask you, find the root. What's the other ways that I could phrase the word root? There's like 4 of them. Somebody give me one.
X-intercept?
Good. X-intercept is one. How else could I say it instead of saying find the root? Solution. Solution. Good job. Find the solutions of the graph. Any more? I can think of one more. Find the zeros. So, yes. So zeros, solutions, x-intercepts, roots, they're all the same thing. Different vocabulary word, but they all have the same meaning. Everybody okay with that? So on one question, I could point to this graph and say, tell me the solutions. On this graph, I could say, tell me the roots. I'm asking the same question. Everybody okay with that? They like to check your vocabulary. So make sure you know all 4 of those vocabulary words. Okay, so let's check this one out. What does this graph show us?
There's 3 solutions.
Okay, so somebody said 3 solutions. And we'll see if that's true or not, because this is where it gets a little tricky. So let's talk about solutions for a minute. So my solutions are -4, -1, and 3. Everybody okay with that idea? But I want you to put a question mark over the -1. There's something special about the -1 because it just barely touches and it doesn't cross at that point. Do you guys see how it changes direction at that point? It comes up to the -1, then it goes back down. So let's take a look at my graph. At the -4, it crosses straight up and down. At the 3, it crosses. It goes straight up and down. It doesn't cross at the -1. So here's where we're going to learn a new word called multiplicity. And this one actually has 4 solutions. And you're thinking, what? How does this have 4 solutions? So I'm going to show you. So multiplicity. Here are kind of the keys to this slide. So if you have it printed out, here's the part I want you to underline. If the multiplicity is odd, it crosses the x-axis. So that's a key phrase. Multiplicity is odd, it crosses the x-axis. Then one more phrase. If the multiplicity is even, it touches the graph. So kind of in my own words, I would write odd equals crosses, even equals it touches. And you're going to get the hang of this really fast. So let's check out the polynomial that I gave you in the notes here. It says x minus 3, x minus 3, x plus 6. So we know for sure that the x minus 3 is going to become a positive 3. Is everybody okay with that idea? For the solution? 2 of them actually. And then the positive 6 would be a negative 6. So how many solutions do I have? I have 3, but kind of in a weird way. So let's graph all 3 of those. Let's put dots at those 2 points. So far we haven't done anything new. We've just taken my factors, we've taken the opposites to find the solutions. So far it's all been the same. Here's the part where it changes how we graph it. How many 3s do you guys see? 2. So this is called a multiplicity of 2. And if the multiplicity is a 2, is 2 an even or an odd number? 2 is an even. So what's going to happen at the 3? It's going to touch. Negative 6. How many times do you see a negative 6 listed? 1. So it's a 1 multiplicity. And 1's an odd number. What does odd mean? It's going to cross. So let's recap what we just did. So because I see 3 listed twice, that means it's going to touch at that point. What's going to happen at negative 6? It's going to cross. So at negative 6, it's going to cross. See how I'm drawing in my graph? At negative 6, it's going to cross. What's going to happen at 3? It's just going to touch it. Kind of cool. So we're going to practice this quite a bit more. Odd multiplicity crosses at that spot. Even multiplicity touches and turns back the other direction. So let's practice again. Because the first time you see something, it's always a little weird, kind of new. So now we're going to come back to that last example that I showed you a minute ago, and we're like, well, I'm not really sure what my solutions are. So I want us to do 2 things. I want us to list my solutions, and then I want you to list your factors. So let's start solutions first. It crosses at -4, so that means how many times am I going to list -4? Once. Everybody still with me? So far so good? Okay, at -1, it just touches and then goes back the other direction. So how many times am I going to list -1? Twice. Great job. How about 3? What happens at 3? It crosses, which means how many times do I list it? Once. Great, great job. You guys did great. So if it crosses, that's a 1 multiplicity. If it crosses, that's a 1 multiplicity. If it touches and goes the other way, you list it twice. Great job. So how many solutions did I really have? 4. Yeah, kind of crazy. I had 4. So let's list my factors now. Let's put these back into factored form. So my x minus, or my -4 is going to become a +4. My -1 is going to become a, I'm going to write them up here because they really need to be side by side touching. My -1 is going to become a +1, but I have 2 of them, right? So I'm going to write it again. And then my 3 will become a -3. There's one last way I can simplify this problem. Instead of writing it twice, I can say x + 1 squared. So let me pause for a second. If you have any questions, please type them in. So it crosses, you write it 1 time. It crosses, you write it 1 time. It touches and changes directions, you're going to write it 2 times. Good job. So if I were to work out this problem completely, this would be an x to the 4th problem. Whatever the highest exponent is tells you how many solutions you're going to have. Isn't that kind of helpful? Kind of handy. So whatever your highest exponent is, that tells you how many solutions you're going to have. Let's try again. So this time it says find the roots of the polynomial equation. I already gave it to you in factored form. You guys are so lucky. So can you please graph that for me? So Kayla, if one of my factors is x + 4, what's going to be one of my solutions? A -4 is going to be one of them. Good. And Billy, if I have x + 1, what's going to be that solution? -1. Okay, but this one also has a -1. So, okay, so let's think about what this means. Do you have 2 dots on your graph so far? Everybody okay? Next to each dot, can you write the word cross or touch? That way you know what to do with the graph at that point. So if it's only listed 1 time, it crosses at that point. If it's listed twice, it touches at that point. Did everybody label theirs okay? So it's going to come up, touch, and go back up. Now, do I really know how high this graph is going? I don't right now because I'm just sketching. I'm just doing a generic sketch. I could figure out this point by trying a -3 and seeing how high or how low it goes at that point, just so that you get an idea. But the test and the quiz just want you to have a general idea of what the graph looks like. They're more concerned with these points.
How do you know if it goes up or down?
Great question. That is what I'm getting to next. So far I've sort of been guiding you guys as to the direction that the graph goes, but how you're going to know, it's based on what kind of exponent you have. So I believe that is 2 more slides away. I will show you that. I was hoping someone would ask that. Okay, so example 7. It says find the multiplicity of each root, describe the behavior at the root. So underneath each of these, if you could tell me what kind of multiplicity it has, and what does that mean? Does that mean it's going to touch or cross? That's all this question's asking me for. So what's the multiplicity, touch or cross? What's the multiplicity, touch or cross? Okay, so Alex, what do you think the multiplicity of the x plus 1 is? So even multiplicity, or you could say multiplicity of 2. See how there's 2 different ways to say it? Good job. And describe the behavior at that point. What would that mean? What's going to happen at that point on the graph? Just going to touch. Great job. Okay, Anna, how about at the -7? What's going to happen there?
It has multiplicity of 1.
Multiplicity of 1, it's going to cross. So we would call that odd. Oops, sorry. Trying to get all my different vocab words in there. And then at the x plus 3, again, we wouldn't graph it at the positive 3 though, right? It would be graphed at the -3. That one's a multiplicity of 1, and it would cross because it's odd. So what is multiplicity? Why do we need multiplicity? It tells us how many solutions you have at that spot. Sometimes you have 2 solutions at that spot. Sometimes you have 1 solution at that spot. Yes?
Can there be solutions that have more than 2? Like, oh yeah.
Can there be solutions that have more than 2? The answer is yes. So we're getting there.
Does anything change when there's like multiplicity of 3 or anything, or does it just cross like as it even crosses the same?
Yes, I'm going to show you some, and I want you guys to discover that answer, but we'll make sure that we get that answered before the end of today for sure. Okay, so on your paper, I didn't give you this chart already, but I think that this one's pretty easy, so we'll just do this one quickly and move forward because I want to get to the ones at the end. So what's the multiplicity at each root? So if I'm pointing to this x minus 1 to the third, you guys would say that it's a multiplicity of 3. And is 3 even or odd? Odd. So what does odd mean? Cross. Okay, so my next one, if it's squared, that would be a multiplicity of 2. That's even. What does even mean? Touch. Good job. Okay, I don't want to spend too much time because I definitely want to get to the next stuff. So multiplicity, even or odd. So when we're taking a peek at my graph, we said before that if the exponent is a 4, that really means that there are 4 solutions. If I have an exponent of 4, again, that means I have 4 solutions. So multiplicity, even or odd, is always dependent upon, you have to factor it first, and then you're looking at the exponent. So you always have to factor first, then you're looking at the exponent. So I'm going to show you a quick way of how to know what your graphs are going to look like. Okay, so on your paper I gave these to you. If it's an x squared, it's going to be a u, both sides. So can you draw these in so that way you have them? Because some of you are saying, well, how do you know it goes up and then down and then back up? If it's an x cubed, it starts down and then goes back up. And then the pattern repeats. So an x to the 4th, both ends go up. And if it's an x to the 5th, it starts down and goes up. So see how it just keeps repeating every other one? Let me throw one thing at you though. These are when your variable is a positive. How do we think it would be different if my variable was a negative? What would that look like?
It would just be the opposite.
Exactly. It would be the opposite. It would be upside down. So what if I have a negative x to the 3rd? I would start high and end low. Negative x to the 4th, start low, end low. So see how it's always going to be the same pattern? So that's how I knew how to start my graphs before. So when we were talking about the x to the 3rd, the blah, 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 and I started down low and drew it up, that's how I knew. They're always going to follow these same patterns. And just a reminder, your number of solutions is always based on your highest exponent. So if I tell you that it's an x squared problem, how many solutions will it have? 2. If it's an x to the 5th, how many solutions will it have? 5. Good job. So your highest exponent will always tell you how many solutions you're going to have. Okay, now we just talked about how to know how many solutions you have, but let me throw this at you. Sometimes when your graph crosses like this would be 2 solutions. This is an x squared graph. Everybody still with me? This is an x squared graph. This still has two solutions. What? How does that have two solutions? Didn't we say earlier that my solutions are where it crosses the x-axis? We did. So if this one doesn't cross the x-axis, how does this one have two solutions? This is what we're learning at the end of this unit, and these are called complex solutions. It's when we're going to have an I in our problem, imaginary numbers. We're going to try one together in a minute. Then your other kind would be an x squared that sort of looks like this. 1, 2, 3. See how this time it doesn't cross on a perfect whole number? These are when we're going to have square roots in our answers. So these are what we call our irrational solutions. So the remainder of class today we're going to be focusing on these last two types. Because so far we are really good now at picking out the two spots when it crosses the x-axis perfectly, right? We're able to do that, not a problem, we can find them. But how am I going to find it if there's an I in it? That's weird, it doesn't cross. And how am I going to find the exact spot if it crosses at a decimal? So we're going to focus our last bit of time together on these last two scenarios. Any questions so far? Everybody okay? Okay, so here's how the question is going to be phrased to you. It will say, how many real roots / irrational roots are there for this problem? So, step number 1, when you guys look at a problem, I want you to pick out the highest variable. Can everybody pick out the variable? What's the highest? 3. How many solutions do we know we're going to have? 3. Okay, so we know for sure there's going to be 3 solutions. Can you guys write that somewhere on your page? The question is, how many real solutions am I going to have? How many irrational solutions am I going to have? And I'm going to show you how to find that. So last week we covered, if it's not factored for you at all, we had to go through and find one solution that would work. So we kind of worked on this. I know it's been a while. There was this thing called the P over Q theorem, where P is all of the factors of your constant, which means 1 times 3. Q is all the numbers in front of your leading coefficient, which is just a 1. Oh, this one's so nice compared to what we did last week. Because look at my only options. 1 divided by 1 or 3 divided by 1. That's really handy. So we know 1 and 3 are my only options. Except I do have to do the plus or minus version. So these are my possible options that would work with synthetic division. So last week we learned sometimes you guys have to try them. We have to try them, see which one works to see which one is actually a solution. So here we go. We're going to do synthetic division. And I always start off with a number that's right in the middle. So if I'm talking 1 and 3, I'm going to pick the 1. I don't know why. Just most of the time it actually will end up working out. So let's do synthetic division. I'm going to drop down my 1, my -1, my -3, and my 3. Okay, so did the 1 work for us? Yes. How did I know that it worked? Because my remainder was 0, which is exactly what I want. So I know that 1 is a solution. Yay! Found 1. Now that I know that 1 is a solution, let's put it back into factored form. So if 1 is a solution, that means x minus 1 is a factor. And now I need to rewrite the rest of my problem. So we started with the cubed. Since I found one factor that worked, now I'm going to take my remainder and I write it going 1 degree less than what I started with. So if I was x cubed before, now this is going to be what? X squared. 0x minus 3. Okay, so one more time what happened right here was we found a factor that worked or a solution that worked, so I'm going to write it back in factored form. you take your remainder and you turn that into what's left over. So this becomes 1x squared, 0x minus 3. So this part's done being totally factored. I still have an x squared, so I do need to factor that. So last week we talked about doing magic diamonds and other ways to finish factoring. Well, this one doesn't have a magic diamond that works. This is why they call these irrational roots. They're not going to be whole numbers. So how am I going to finish solving this? Let me show you. Well, to solve, we know we just set it equal to 0. Am I right? Everybody okay with that? I'm going to do the same thing here. Can we set this equal to 0 and solve? Let's try. Let's see what happens. So let's add the 3 to the other side. I don't want to know what x squared is. I just want to know what x is. Who remembers how to get rid of a square? Good job. You're going to square root both sides. So x is going to equal, and it's always a plus or minus when we're doing square roots, plus or minus root 3. So one more time, what did I do? I set my first parenthesis equal to 0. I got a whole number. Yay. I set my next parenthesis equal to 0. Got x squared equals 3. So we had to square root both sides, and we get x equals plus or minus root 3. So I have one real solution, and I have two irrational solutions. So let's write that in my box. So I ended up with one real solution and two irrational solutions. What does irrational mean? It just means it's a decimal. If we were to type square root of 3 into our calculator, it's just about 1.7. So that's why we weren't able to find it with traditional factoring, like we did the 1, because it's not a whole number. Okay, so by the time I was done factoring, I got one real solution and we had two irrational solutions. So on a graph, just kind of throwing this out there so that we have a full view of what's going on. So one's going to cross at the 1. One's going to cross at a positive root 3, which is probably right here. One's going to cross at a negative root 3, which is right here. Because it's an x to the third, do we kind of remember the shape? It starts low and then goes high on the other side. This one's going to go like this. Cross, cross, cross. If I'm able to draw in a line. It would look something like that. I have one more for us to try. So the big idea is from the very beginning, you guys are able to pick out, hey, it has an x to the third. I know there's 3 solutions. Then we have to factor in order to find out how many of them were real answers and how many of them were either irrational answers or what we're going to have in the next problem called complex answers. So let's try again. So how many real roots / complex roots? And this is our last problem of the day. Oh, good answer. Okay, so before we start, we already know I'm going to have 3 total solutions. Everybody okay with that idea? So let's put that in a box off to the side. You're right. You know that right off the bat. But how many are real? How many are complex? We don't know yet. Everybody on the same page with me? We know there's going to be 3 total. We just don't know how many of each we're going to have. So how do I start factoring this thing? What were my first steps on the last problem? Plus or minus P over Q. So my P is going to be my factors of 5, so 1 or 5. Q are my factors of my leading coefficients. That's just a 1. We love when that's a 1 on the bottom. It makes our life way easier. So my only options are going to be plus or minus 1 and plus or minus 5. So that means using synthetic division, I either need to try a positive 1, a negative 1, a positive 5, or a negative 5. Let's start in the middle. So let's start with, what do we want to try?
Positive 1?
Positive 1, sure. Because if we can find a positive that works, isn't it much nicer doing a positive than a negative? If we can find one. What do you think? Did we pick a good one? We did, yeah.
Is there ever going to be a time when like there's more than one solution, like more than one solution, basically?
So what Billy's asking is will there ever be a time when more than one of these work? And the answer is yes. Yep. And you can use either of them. Yeah, because watch what happens after we find one of them. So after I find one, I'm going to take that one and write it as its factor. Then I'm going to take my remainder down here, and I'm going to rewrite that, going one less than what it was before. So if I started with the x cubed, that would be 1x squared, 0x plus 5. Okay, so I know I'm going to have 3 solutions. Everybody still on the same page? We know that one of them is a 1, which is a whole number. It's a real root. How am I going to solve this last part of my parenthesis? We could either try a magic diamond, but that's not going to work in this case. So what did I do in the last problem? I set it equal to 0. Can you guys do that again? One of the reasons we're allowed to just set it equal to 0, you guys, is because there's no middle x term. Do you guys see how that middle term is missing? Whenever you just have an x squared and the number at the end, you can always set it equal to 0 and solve algebraically. So I get x squared plus 5 equals 0. We're going to move the 5 over. Uh-oh, I get x squared equals negative 5. How do I get rid of the square? Because I don't want the square. Square root both sides. So x is going to equal plus or minus the square root of negative 5. But didn't we learn about negative square roots earlier in the year? I know it's been a while. A square root is really what number times itself can get you that value. So does anybody remember what we learned about negative square roots? Nope, not quite. This is where our imaginary numbers come into play. So what we learned how to do is all we do is take the negative, and the negative gets to come outside as an I. So we're going to say that this is plus or minus I root 5. Sorry, that's a really light pen color there. So it's going to come out as an I. The negative always comes out. So plus or minus I root 5. So I had 1 as an answer. So I had 1 real root. And then I had that plus or minus I root 5. So that means plus I root 5 is an answer and minus I root 5 is another answer. So I had 1 real root, and these are called 2 complex roots. So it's called complex if it has an I in it. It's called irrational if it has a square root in it with no I.
So if it's a negative square root, it's going to be complex, but if it's irrational, it's going to be positive.
Perfect answer. So what Anna was saying is that if it's a negative square root, it's always going to be complex, and that's right. If it's a positive square root, it's always going to be irrational. Really good job. So from the very beginning, you knew how many roots to expect, correct? From the very beginning. We just had to figure out how many of each one by using our P over Q, finding a factor that worked, and then setting our second part of our problem equal to 0 and solving. Good job. It's a lot. This is like a really big, hefty unit, but I think you guys have done a really great job. So to wrap up today, your week 4 essential question is, what is multiplicity, and what does it tell us about the graph at that point? So Gabriella, just make sure you put your answer in the Dropbox for me, and I hope that everyone watching online has a great day. Thanks.
Do we have to